All right, well, welcome to Data Structures. I am Dr. Paul West. This is Data Structures. Anyone here in the wrong class? I'm always waiting for someone to raise their hand and run out. No? Okay. All right, so this is Data Structures. There's a lot of moving pieces that are going to happen in this course. Up to now, most of y'all have been basically just taking code and probably copying, pasting it, and putting it together to try and solve the problem so far. But in Data Structures is where we're going to do a huge transition from basically manipulating code to here you have a bunch of tools that you have learned throughout your career so far, and we're going to hopefully go through and teach you how you take those tools and you create something in the end. And that's what you're going to do a lot of times in the workforce, so this class is actually very important to help move on. And if I actually do accomplish my goals correctly after this course, you should be able to actually join either a job or an open source project and be able to start contributing as a programmer. So that's one of the big goals, but the subject material is something different, is data structures, which is how we're going to organize our data so that we can both efficiently access it. And when I say efficiency, I'm saying both quickly and so it's easy for programmers to use. One thing to keep in mind is nowadays, the programmer is way more expensive than the computer. You know, back in the 50s, it was the other way around, but nowadays, we also need to keep in mind making everything easy for programmers to use as well as fast. So, oh yeah, before we begin, anyone do any programming over the summer? Just a little? Oh, what'd you do?
I had an internship.
Oh, cool. With, who'd you intern with?
I was at ACS Technologies in Florence.
Oh, okay, in Florence. Okay, cool. Did you, what project did they have you on? I guess is the best way to ask.
We were working on a project portfolio manager.
Oh, okay.
So I was doing most of the front end design.
Oh, okay. Front end design. Great. Yourself?
I had an internship also, but I worked at Netizen here in Charleston.
Oh, okay. And the project, what was the project?
I worked on an auto stig tool.
Oh, okay. So an auto stigging tool. All right, to go through all the different security checklists and whatnot. Yeah, okay. Okay, cool. All right, well, got things started. That's great. I worked at NRL, Naval Research Lab, a little, which was a lot of fun. But anyways, let's get back to the data structure. What's a data structure? So the scheme for organizing the data, over here on the right, we have a picture of a binary tree. Some of the more commonly used data structures that you'll see, what we have here: list, arrays, stacks, queues, heaps, trees, and graphs. Y'all have probably seen some of these, at least in OOP, with lists and arrays. Did y'all do stacks and queues? A little? Stacks?
Yes.
Queues, no. You probably did not do heaps or trees and graphs. Although in OOP, did she talk about the different types of memory, now that we say the word heap, which was static, stack, and heap? Okay, great. So we got that. Heaps, by the way, there's a heap data structure that has nothing to do with heap memory, just to confuse you a lot, but we'll get to that later. So why do we do this? We want to be able to organize the data for performance, and computer programmers, one of the things that they need to do is decide which data structure to choose. We're no longer in the realm of there is one choice that's better than the rest. Now you must select between different data structures to find the one that fits your needs the best. So hopefully I will help you develop tools in order for you to assess and decide which one is the best to use. For example, one is a queue, which I guess you didn't have a stack, but a queue is a word we use basically in the rest of the world, and in America we use the word line. It's the same thing. So the idea is the first one that goes in is the first one to comes out, and then you queue it up. Like a checkout line in a supermarket. But on a computer, can anyone think of when a queue would be used? Command prompt? So how in the command prompt a queue?
Say about lines.
Lines, okay, like you have one line, it executes and it goes to the next. Oh, okay, yeah, you can think of that as a queue.
I mean, like entering like your credit card information online, like the authorization and all that.
So I think I see where you're going with that, because it looks like you're putting in a queue of information, but generally with static pages, it's just one giant data block and they ship it through. But that's a good idea. close. I mean, a way you can think of the queue when you're typing, you know, you have this character and that one, but any more of a broad, those aren't bad. I'm not saying they're bad, just more underneath. So another example is when you print. In general, when you send something to the printer, it's done in the order it's received. And when it receives one item, it may receive, you know, 10 more before it can finally finish printing because, you know, interacting with the physical world takes a long time. So it'll queue everything up. Over here is a binary tree, which is actually a way to organize data. And quick look ahead. So in a binary tree, basically the red and the blue are going to be two pieces of data. And the green is the, I'm sorry, I said that completely wrong. Scratch what I just said. The green holds the data. Think of the green as an integer. And then the red and the blue are a way to point to the next element. Now, I'm going to ask you why would we want to do it this way. But before I do, let me tell you a big hint about a binary search tree. If you have a number up here on the top, and let me use my pointer because we do have one online student. If you're up here, everything to the left is going to be less than that value, and everything to the right is going to be greater than it. And that property is going to hold true for everything. So when you're on this one, everything to the left is less than, and everything to the right is greater than. So if you wanted to search for something in here, how long would that take?
Not very long because you either have the choice of going the right path or the left path, depending on whether the number is bigger than the previous.
So let me jump back a little. If we're in a queue and we need to find something, how do we find it? We got to go through the entire queue. So if this queue is 1 million in length, we got to go through 1 million elements. Probably going to find it halfway through, so we go through 500,000 elements. We're over here. We're up top. We need to find an element. Let's say it's not this one, but we know it's bigger than it. Do we need to go left? No. No. So we've just chopped off 500,000 elements of search by just organizing our data this way and being able to jump in. What actually happens is you chop off 500,000, go here. We'll say it's less than, so you chop off the right. Now you've chopped off 250,000 elements, so forth and so on, and it ends up being substantially faster in the end. You kind of get high level the difference here. Notice that these two data structures are used for completely different things, because a binary search tree is for organizing data, searching for it, while a queue is for keeping track of what's going next. All right, pointers are lined up, and we'll go more into pointers. Did y'all talk about pointers in OOP, or did you just talk about references? Just, you can give me the blank stare of I have no idea what you're talking about. I understand. I just want to know. So when do you choose one over the other? Wow, I just answered that question. Well, sorry about that. Right. In reality, the answer is it depends on what you need to do. Okay, a little bit about me. Let's see, PhD from Florida State Computer Science. I've worked at Charleston Southern since 2015. I'm now an associate, great. I was adjunct for 2 semesters at CFC. Work experience, I do have a part-time job at the Naval Research Lab where I work on, I'll say a systems programming, low-level operating systems coding. I did work at Google for a while, so if you want to ask me about that, it was a lot of fun. I have done other SPAWAR contracts. I guess I need to use the word NIWC now. And I did work at a startup. So the big couple of takeaways here, I have a diverse experience. I've worked in government, a large company, and Denim Group, which is a startup company as well. So if you have any questions about those 3, please feel free to ask me. They each have their pros and cons. I'm not going to say one is way better than the other, but it all pretty much depends on what you want to do. Also keep in mind that, good morning. I'm a low-level developer. I don't particularly use a GUI that much. I mean, I am here because I need to display things, but you'll see very quickly, I'm usually just sitting on the command line typing away. Do you have any questions for me? No? All right. Okay, first goal, just make sure we're all on track. we want to finish the foundation for computer science. So this class really is to sit down and make sure we have the foundation built. And in a way, pretty much all your other courses are going to come from this course. So we're going to lay down how to, basics of how programming, how you think about it, how you should think about efficiency, how you do testing, how you set up different components. And then when you go into other classes like algorithms or architecture or software engineering, hopefully this course will lay the foundation for those. And like I said, before data structures, you basically just copy-pasted everything, then reworked it, and then submit it. I'm assuming that's what most of y'all did, which I don't blame you. That's how you have to learn. Now you're going to have a bag of tricks, basically a bunch of tools. You've learned about loops and functions, and now I'm going to give you data structures, and now you're going to have to solve a problem that comes up. Figure out what tools to use for the problem. How do I assess this? All right, this is where you need to understand why data structures has so many assignments. In order to assess this, the best way I've learned to do this is to just give numerous programming problems. I don't give a lot because I'm trying to make it hard. I give a lot so you don't have to do giant projects the entire time and get lost on one project and then lose 30% of your grade. There's just numerous programming problems I use to break it up. I'll have you fix broken code. Don't assume that the code we write in class is correct, because it is not. It will not be. I can basically guarantee you that. Fix performance issues of existing code. Again, the code I give may not be the correct performance. Also, other code in your projects may not have the correct performance as well. And then basically show me you understand how a computer assembles your program together, which we'll get to with makefiles in, I think, lab 3 or 4. Other goals, be able to analyze a problem, find errors, any performance, talked about that. Generate reports. One thing I think is very important is not only talk about theoretically how we do performance, but also how to empirically deduce the performance issues of your program. So there's going to be certain tools we will use to find your performance issues. And also, this is probably the first class where you'll be introduced into a Unix environment. I am a heavy Linux user, and so this is a good natural fit also because beforehand y'all were probably all using an IDE. Was it in JetBrains or IntelliJ or NetBeans or something? NetBeans, all right. I don't use an IDE for this class. And don't use one for this class. And it's not that I'm saying IDEs are terrible. I use them for certain projects. Like if you have a giant Java web-based development project, you're going to want to use an IDE. But there's a lot of things you need to learn about how an IDE assembles your program so you'll appreciate what it's doing and how to debug issues that come up inside your IDE. Okay. So this is in a Unix environment or Linux. I use Debian. You are free to use other ones as well. I highly recommend you virtualize a Unix environment of some sort on your laptop. I'm assuming everyone here has a laptop. Good. That's been a safe assumption for a long time. Great. I recommend you just install VirtualBox and you run Ubuntu, Mate, or Mint, or something like that. Just get it up and running. Make sure when you load it, you click Install to hard drive. Make sure it installs and then reboots the hard drive. If you do the live edition, any work you do under that virtual machine will be deleted once you reboot the machine. So make sure you install it first. Otherwise, you're going to be really, really sad. Another option is actually bash on Ubuntu on Windows. And I got this to work just fine so far. There might be a couple of issues that you run into, and which is why I still recommend using Ubuntu. But versions 1703, that's of Windows 10, had Ubuntu 1604. Go ahead and install that version. 1604 seems to work with almost everything in this class. There's one performance lab that it doesn't quite work with, but you can do something else with that. Google how to install. This isn't rocket science. I think you just go to the Microsoft store and you hit do it. You may use the machines here in class, which have bash for Windows, but the only issue is you have to install it for your user, which means if you use this machine, it'll install, and then you have to go, if you go to another machine, you're going to have to reinstall the whole thing again. So they don't make it super nice, but it's working. Other options, so Mint or Ubuntu are the two that are probably going to work the best. You can use Fedora or CentOS if you want to. I don't see why those would fail, but I don't like them, but they should work fine. I have had a couple of users try OS X Mac, but they go through a lot of pain. I highly recommend avoiding it. If you choose to, make sure you install everything from Homebrew. Do not use the native Mac installs. It will not work very well. You can try and use the Windows command line interface, you know, command.prompt, but I believe you will be very, very sad. No one's really gotten that to work. And then there's BSD and Solaris. Do we have any BSD or Solaris users? No? Waiting for one day, but someone comes out and says BSD all the way. But, oh well. Solaris is kind of dying. Those two, by the way, are other Unix type environments. Linux is type of Unix. BSD and Solaris are as well. All right. Why am I basically telling you to use the command line instead of an IDE? Well, one, so you understand what's going on under the hood, of course, because it makes you understand it. And also, most GUIs are actually paint on top of what you're running on the command line. But also, there's this, I love this graph of tasks. So in this graph, it shows why basically the difference between how a geek and a non-geek will approach a problem. So the idea is that notice on the left is how much time is being spent, so time spent increases. On the bottom is how large the task is. Obviously, the task size is really small. Both people are not going to use much. Everyone just does it manually. But at some point, the geek gets annoyed and decides to write a script to automate the thing. And there's this large cost right there. Let me go back to the mouse pointer. There's this cost right here before they see any benefit. But once you run the script, it's basically no cost to do anything. And of course, the non-geek has no idea how to write a script, so he just does it manually for as long as he can. And then eventually, the script will always win due to automation. Now, since you are computer science people, most of your problems are going to be on the right side of task size. So it's important for you to at least start understanding scripting. Have you all taken scripting yet? Some of y'all have? No? Okay, so some have, some haven't. That's fine. That's fine. Make sense? No. I do get a lot of students who say data structures are difficult. That's why I have so many slides to help you understand what to do. This is more of a marathon, not a sprint. Numerous labs are to break up the work, not to make it painful. Last semester was 25 labs and 4 projects. That's going to be roughly how many it is this time. I may have a 5th project just to break up one of the projects into smaller projects so it's not as, I guess, hard to do. Warning, this is still hell. The pass rate of a student becoming 3 weeks behind is still 0%. Think about that, all right? If you are 3 weeks behind in your labs, I have not had a student recover yet. So if you fall behind, if you're 1 week behind, the students generally can recover from that. 2 weeks, it's not good. If you fall behind, please come see me. I can try and help you out. I can tell you what to do. I had one student who took data structures, Calc 2, and had football where they went to playoffs that semester. So he was on the football team, and he did all 3, and he passed everything. And this is his advice, which is probably going to be very helpful. Make sure you do data structures in Calc 2 each day. Don't get behind. I don't know how many times I can say that. If you cannot get a lab done, make sure the lab compiles and submit to get what points you can. In this class, if your lab does not compile or your project does not compile, that it is a 0. Don't come to me, it's a 0. It did not compile. It is not acceptable anymore for your program not to compile. Make sure it compiles. The compiler will throw every error at you until it finally compiles. Make sure it compiles. Yeah, I think I've said the word compiles enough now. If you fall, his last piece of advice, and this I have to unfortunately tell you is true, if you fall behind, don't try and catch up. Take the 0 and move on to your next lab. That's just going to be the best way to do it. All right, syllabus. Any questions before I start the syllabus? Nope. All right.